Monday. Okay, like I said, we're going to cover a bunch of material today, and then I've got your test, and I will let you see them at the end of this class. So I'm going to try and get started now so that we have time, okay? Good job on the test, though. Overall, I think the test grades were good. If you're struggling in the class and you want to talk to me, please just let me know, and we'll set up a time to work. Today, what we're starting on is really rational expressions. And when you think about rationals, most of you would think about fractions, okay? Not your favorite thing, but when they say rational, it's really just a relationship of one number or one system of numbers to another, and so it's really just a fractional format. So I gave you some examples here of what rational expressions might look like, and you'll note that there's always a numerator and denominator involved. And so what we do with them is there's lots of ways to simplify them. Remember me telling you that factoring was going to be a part of your future from now on, and that everything we did from now on would involve factoring? Well, rationals do involve factoring to simplify them. So if factoring is still a struggle for you, it's still going to really hurt you in the rest of this course, okay? So it's time to figure out the factoring issues. Now, how do you do it? You simplify them by, and I've given you some steps, you factor both the numerator and the denominator, and then you cancel everything that's alike. Bottom line, okay? So let's take a look at this one. It really says 7y minus 14 over 9y minus 18, and as it is, they do not reduce. The reason they cannot reduce, note this, okay? There's addition or subtraction or both in either the numerator or the denominator or both. In this case, there's subtraction in both of them. So if I had all multiplication, if everything here was multiplied in the numerator and all of these terms in the denominator were all multiplied, we wouldn't be doing what we're going to talk about doing now, okay? You'd simply reduce, because once everything is multiplied together, they're simply glued together as like terms. So we would, I think I was saying, we would just simply reduce them if everything was multiplied, right? But since it's not, that's why we have to go to some other extremes, and we're going to have to factor and see if we can find common factors. And common factors, same in the numerator and denominator, will reduce. So what do we do with this numerator? Well, we look at them sort of like separate problems. I can factor out a GCF here, can't I? So I'm going to come over here and say this is really a GCF of 7. When I factor that out, I have it would be 7 times y minus 2. You should be able to do that pretty quickly by now, okay? So I factored out the GCF of 7. Down here, these two terms, I have a GCF of 9. So I'm going to be able to factor it out. Well, 9 times y would get me back to the 9y. 9 times a negative 2 would get me back to the negative 18. What did I do? I, in essence, did the same thing we've been doing. I just divided each of these terms by 9. What was left over was my binomial factor. Now I see that these binomial factors match each other, and that means they can be reduced. The reason is because they are now multiplied, right? Anything that's multiplied, multiplication allows me to reduce. So what do I have left? Well, I just have 7 over 9. If I could reduce that fraction, I would, but it doesn't. So that was pretty simple. The next one is a little more complicated, and the only reason is it's trinomials, right, instead of binomials. So I'm going to have to factor these first step, and on the test, some people miss this. The GCF always has to come out first. But I'm looking at this top one, and I don't see a GCF. So I'm going to go ahead and make sure I don't forget that it's a rational. And I'm going to say I'm going to factor it. I'm going to try to factor it. Who knows? It might not factor. Into two binomials. I look at the second operation. It tells me to use one of each sign. I go ahead and I factor that x squared. Now, I'm going to come over here, and I'm going to say, okay, can you see it? I'm going to come over here, and I'm going to go, okay, this is 2 times negative 21. That's a negative 42, isn't it? And I'm coming down here to the negative 11. That's the b term. And this is another thing that was confusing to some of you on the test. What do you put in the top of these fractions? Well, you put always the coefficient and then the square root of the variable. The coefficient goes in both of them. Are you here for? Come quickly and get it. Make sure everything else is off your desk, including your cell phone, okay? And bring it back to me when you finish. Okay? All right, next, what do I do here? Well, I'm going to factor negative 42. I'm going to see if I can come up with factors that will combine to give me a negative 11. And sometimes the negatives do give us trouble, I understand. You just got to work enough problems that you get it right. You know, if you don't see it, you start with 1 and 42, and then you go 2 and 21, right? And that's not working. Will it divide by 3? Yeah, it'll divide by 3 because it's it passes that little trait I've got, and I say 3, and it would be 14. And that's where I find it, 3 and 14. So I know I need a negative 11, so I'm going to have the larger one is going to have to be negative. So I will put negative 14 and positive 3, and then I'll try to reduce those fractions. 2x plus 3 does not reduce, so I can go ahead and say 2x plus 3. 2x minus 14, I'm going to divide them both by 2, and I'm going to have x minus 7, which is my second factor. FOIL it to check it. 2x times x is 2x squared. 3 times negative 7, negative 21. This gives me 3x. Inside gives me 3x. Outside gives me a negative 14x. And I need a negative 11x, and that did combine correctly. Okay, so I factored the top one, and I've got to try to do the same thing with the bottom one. I'm going to say this plus tells me to use the first sign for both of them. This is a simple trinomial. So all I have to do is put x's there. And then I'm going to come down here and say, okay, I need this to be a positive 14 and this to be a negative 9. My sides are x and x in the top. And I'm going to say, what am I factoring? Factors of 14 that will combine to give me a negative 9. And I always start with 1 and 2. And look, I think I found it, right? How am I going to get this negative 9? Well, they both have to be negative to combine to give me a negative 9, but that's what I need. Negative times negative to give me a positive, and I already set the sign, so there's several ways you can check yourself here. So I've got a negative 2 and a negative 7, and those are my factors. I check it. X times x is x squared. Negative 2 times negative 7 is a positive 14. This gives me a negative 2x. This gives me a negative 7x, which combines to give me a negative 9x. And I'm good. And now I can see this, everything in parentheses, we treat as like they're single terms. They're being multiplied, therefore they can be reduced. What's left in this one? Well, I've got 2x plus 3 over x minus 2. There's nothing I can do. I don't need the parentheses anymore. I can simply leave it like that because there's no way to reduce it anymore. I took out all the common factors from those two. Okay? All right, next. We have a trinomial over a binomial. That binomial looks pretty simple. I don't think it's going to reduce at all. I'm going to go ahead and put it in parentheses because if it's going to be reduced, it's going to have to reduce as a single item. In other words, it's going to have a matching binomial in the numerator. So I'll just put it in parentheses to remind myself of that. I come over here and I factor. I look at the second operation to get my signs. I factor the x squared, and I create the diamond. I say 1 times negative 14, and I say negative 5. I create the sides, which is x and x in both of them. This should be like a piece of cake by now. And now I'm saying factors of negative 14 that combine to give me negative 5. And I realize I'm going to have one positive and one negative, right? So I'll just kind of play with it here. And I found them pretty quick, 2 and 7. You may have seen it right away. Which one needs to be negative? Yeah, the bigger one, because I got to come up with a negative answer down here. So I'll say this is a positive 2 and this is a negative 7. And what do I still have in my denominator that will reduce, right? So the x plus 2's cancel. What's left in the denominator is simply a 1, isn't it? So I can say this becomes a whole number, It's x minus 7 over 1, which I don't have to write the over 1 part, do I? Are you good so far? Yep. It's just taking factoring and using it. This is the reason we learned to factor in the first place, okay? All right. Now this one I put in here deliberately because I want you to recognize this type of problem. Look at this problem. It's x minus 11 over 11 minus x. And without doing anything, you should know, when we finish this, you will know that this is a negative 1. It will always be a negative 1. The thing is, you're looking for this. This is a positive x in the numerator, negative x in the denominator. Negative 11 in the numerator, positive 11 in the denominator. They're opposites, aren't they? Aren't they the same terms, the opposites? Okay, let's prove what I just told you, okay? First thing we're going to do is make this one just x minus 11 because we can't do anything with it. And we're going to turn this thing around. We're going to call this negative x plus 11. And now we're going to try to make them match. Well, the only thing I can factor out is a negative 1. But when I factor out a negative 1, this becomes x minus 11, right? Okay, now these will reduce, won't they? Well, nothing's left in the numerator. I could say 1 is there. But what do I have? I have 1 over negative 1. Which is negative 1, which is what we said, right? So anytime, and you should memorize this, you should learn this, you're going to need this, okay? If you're going on into college algebra, you're going to be expected to know this one. Anytime you see binomial, same terms, opposite signs, you can say, well, that's negative 1, okay? Piece of cake, right? Okay. Next one, let's look at this one and see if we can sort of apply the same thing down here to this second example 5. First of all, I look at that numerator and you should see perfect square minus a difference of 2 squares. A difference of 2 squares is that easy factoring method. 1 of each sign, square root of the first term, square root of the second term, and we are done. That's pretty fast, and hopefully by now you are just that fast with it, okay? If not, practice. All right, next, I'm going to turn this around because I want the x variable first. I'm going to say this is negative x plus 7. Well, that doesn't match anything, does it? But what if I factor out the negative? Take the time to write it down, okay? What if I factor out the negative? It becomes a negative 1 times x minus 7, doesn't it? And now I can reduce it with the x minus 7. Now what is this really? Well, it's x plus 7 over negative 1. But I'm going to bring the negative to the numerator just because I don't really leave a negative in the denominator. I think I can come down here and write this just as easy. I'm going to say this is negative 1 times x plus 7, isn't it? Over 1, which I don't care about the over 1 part, do I? Well, you can leave it like that. You could say it's negative x plus 7, or you could write it's negative x minus 7. I don't know that my lab math cares which method, but those are the same thing, right? Are you okay with this? It's not so bad once you've got factoring under your belt, right? Okay. Next page, we'll go on as soon as I'm going to give you a breather just a second. I'm giving me a breather. Okay, ready? Next page, let's look at this section. This says, how do we multiply? If we have rational expressions and we want to multiply them together, I want you to remember one principle. Don't ever multiply anything until you have cross-reduced. True fractions, you don't ever want to multiply and then reduce. You reduce before you multiply, okay? So if I've got factors that will cross-reduce, anything in the numerator will reduce with anything in the denominator as long as everything is multiplication. We can do that. I do that first. Now, this one looks like maybe I can factor out a GCF. So I'm going to factor it down as far as I can and then start my reducing, okay? I'm going to say, for this numerator, I'm going to factor out a 4. I end up with 2x minus 3. That's as basic as it gets. That's all I can factor out. There's nothing I can do about this 5. I'll leave it as multiplication. There's nothing to be done about a 10. But down here, I have a negative 2x, don't I? Plus 3. I'm going to go ahead and rewrite it because I know I'm going to need it in that format. You can cross it out so you know that we've replaced it, right? So I can factor out a what? Well, let's factor out a negative 1. And then we have 2x minus 3. That's convenient, isn't it? Anything, since this is all multiplication, it's like saying 4 times 2x minus 3 times 10. Anything that's all multiplied, I can reduce, I can cross-reduce. Anything in the numerator with anything in the denominator. So I'm going to start doing that. I'm going to go 2x minus 3s. Well, I got rid of my binomials. All I'm dealing with now is numbers. Well, what about 5 and 10? This will be a 1, and this turns into a 2, doesn't it? Well, I sort of simplified that. So this becomes 4 times 2. That's all that's left in the numerator. 1 times negative 1 is negative 1, isn't it? And what's 8 divided by negative 1? There you go. So that whole expression just reduced down to negative 8. Okay, simplified. All right, we've got more work to do, it looks like, with the second example. So first I'm going to say, let's just come over here and say, see if we can start reducing or start factoring. I see a GCF of 24. Hang on, I just need to make a note on my notes real quick. I see a GCF of 24, and then down here, I see a GCF of 9. Well, as it is, those don't look like they're going to do too much for reducing. I mean, I know I can reduce a 3 in both of these, but let's see what else happens. Over here, I see a GCF of 3. What's left is x plus 5. And down here, I'm going to say, okay, that's going to bring out a GCF of 6, x squared minus 1. Now, I'm not going to stop this until I have factored everything. Listen to this word, completely factored. Am I through factoring? I have an x squared. I have a perfect square. Do I have a perfect square here? Do I have a minus in the middle? What is this? What do we call it? A difference of two squares. How do you factor a difference of two squares? Well, let's factor again, okay? I'm going to come down here under it and factor it. One of each sign, square root of the first term, square root of the second term, and then I'm going to draw a line through it to show that I just replaced it with that factor, okay, with those factors. Is everybody good? If not, you rewrite it, right? Now, everything in the numerator can reduce with anything in the denominator. And I've got an x plus 1 here and an x plus 1 here. I've got an x plus 5 here and an x plus 5 here. It's beginning to look a little jumbly. Be careful when you're doing this. Some of you need to write neater. I've been grading your test papers, okay? So let's see what we can reduce. I see, and you can start anywhere you want to, right? I see a 3 and a 6. Well, that becomes a 1 and this becomes a 2, right? This x minus 1 isn't going anywhere, so I'm just leaving it alone. And then I've got a 2 here, and I've got a 24 in the numerator. Can I reduce those? So this becomes a 1, and this becomes a 12, doesn't it? All right. What about 12 and 9? You can go take it, keep taking it as far as you can take it. Divide them by what? This becomes a 4. And this becomes a 3. I think I'm done, but let's go ahead and get rid of all the stuff we've crossed out and see. In the numerator, I've got a 4 multiplied times, well, all of these that I've crossed out become 1s. 4 times every 1 up there is just a 4. In the denominator, I've got a 3 multiplied times an x minus 1, right? I don't see anything else. Did I miss anything? I'm very tired today, so you're going to have to check me. Are you good? Am I good? Okay. So it's just really one step at a time. And you can do these many different sequences. I mean, the order I just did it in is not important. The end result should be the same. All right, let's see. Let's talk about the next step. We talked about how to multiply fractions. Do you remember the rule for dividing rationals, dividing fractions? Keep the first fraction the same. And what do you do to the second one? You change it. You flip it, and then you change the operation to multiplication. It's the same thing, okay? So what we do is we take the reciprocal of the second fraction, which means we flip it, okay? You flip the second fraction. So I'm going to rewrite this thing. Before I do anything else, I'm going to say this is really x squared minus 16x plus 64 over x squared minus x minus 56 times 4 over x squared minus 64. Now, so all of a sudden, division just became the same thing we've been doing. It just turns into multiplication just that easy, okay? So just remember, don't divide two fractions, you multiply by the reciprocal. Now, only thing you've got to remember that I've seen people do wrong, listen to me, okay? The first fraction has to stay the same. Don't flip the first one. You have to flip the second one, okay? If you remember that, you're golden, okay? All right, let's see if we can factor this trinomial here. If I say this one is going to factor into, let's try it anyway, right? Binomial times a binomial. I know I need two negatives. I know I'm going to get the square root of the first term. Not explaining that, but you guys know where it's coming from, right? I'm going to come over here, and I'm going to say I need 64, and the end result needs to be 16. I've got an x, and I've got an x. And some of you may have already recognized the fact that this is a perfect square, and this is a perfect square, and that's going to be the sum of the two square roots, right? But you can do it this way, too. You can say, what factors of 64 would give me negative 16? And hopefully you would recognize without going through the list that it's 8 and 8, right? What's it going to be? Well, it has to be negative 8, doesn't it? We know that. We have our operations already set. We know it has to sum to a negative 16. So, negative 8, I FOIL to check it, and I'm good, right? Okay, do the second one. Down here, I'm going to say, okay, binomial times a binomial for that one. That minus says I need a plus and a negative, I need an x, and I need an x. And I'm going to come over here and say, okay, how does this one work? This one is a negative 56 and a negative 1. Well, that's not so easy, is it? But then I have to think about what are my factors of 56? Well, negative 56 means one of them is going to be negative, one's going to be positive, and I will be subtracting. But do you see it automatically, or do you need to work through it? Because if you need to work through it, you simply say 1 times 56, 2 times, I don't even know what that is, 8, 20, is it 28? No. Sorry, guys, my brain is really fried. 2 times, somebody divide it for me. 28, was I right? Okay. And then I go 3 won't work, and 4 does work. 14, right? 4 and 14. You can do it with a calculator a lot faster than I'm doing. I need a negative 1. What did you end up with? 7 and 8, which you probably saw already, right? So you don't have to work your way through it. If you see it, I need one of them to be positive and one to be negative, and I need the answer to be a negative, so the bigger one's negative, right? So plus 7 minus 8. It's not really hard, is it? Okay, that's good. Let's finish this one. 4, and this is, once again, a difference of 2 squares. So we factor it as a difference of 2 squares, and now I'm done. Now I can start reducing. Well, here's a x minus 8 and an x minus 8. There's another x minus 8, x minus 8. I can't really do too much here, can I? Did I miss anything? my notes are wrong. I was really tired last night when I did this too. What's left up here is 4. What's it over? Well, x plus 7 times x plus 8. That's all that's left, isn't it? Are we okay? Now, would you multiply that out? And you could FOIL it, but MyLab Math should take it just like it is. Factored is fine. And most of the time we leave these things factored so that we can see that nothing reduced. Nothing else would reduce. Okay, the next one, division. Hopefully you're working ahead of me and you're already there. If not, go for it. See if you can do this one, okay? Okay. First thing we're going to do is fix it. It's a plus b, which I'm going to put in parentheses because I can't factor them or reduce them or anything. And I'm going to say it's multiplied times, and that's going to be 5a cubed b over a squared minus b squared, another difference of 2 squares. So I'm going to come down here and go, this is really a plus b over AB. I've got a lot of reducing to do. That's why I'm going to the trouble to rewrite the thing, because it can get messed up. And here's my difference of 2 squares. Now I can start reducing. Everything's multiplied now. Everything else that's not is inside parentheses, so we treat it as a single item. And I can say, okay, this a and this a cubed, well, really, if I reduce that, it's going to leave me with a squared. B and b will cancel each other out. And then what I'm going to really have left up here is going to be 5 times a squared. In the denominator, all I've got left is a minus b. Now, tell me why I can't reduce the a's. Well, exponent, but that's not why they don't reduce. Why does this a not reduce with that a squared? Okay, I think you guys know the answer. You just maybe don't know the words to explain it, but that was close. This is multiplication. This is not. Do you understand? What helps us, what allows us to reduce? Everything multiplied. If it is not, you cannot unless every term reduces. In other words, this one and this one and this one would all have to have an a in them. And that b, negative b, does not. Do you understand? Okay? So the only thing you're going to be able to reduce is all multiplications, or if they all have the common factor. Okay, next. Am I on this page today? I can't remember. Give me just a second. Yep, we're going to go through this, and this is our last page, so we'll have time for you to look at your test, okay? So this is adding and subtracting. Now, granted, addition and subtraction of fractions is always harder than multiplication and division. Okay, it's always harder because you have to have a what? Yeah, you have to have a common denominator. You're going to be looking for that least common denominator. You're going to have to convert the fractions, remember? So you got to have the denominators the same if you're going to be able to add and subtract the numerators. All right, so this one, I'm looking at 2 fractions, 6 over 7x, and this is minus another fraction, x plus 2 over 7x. have the same denominator, don't they? Now let's go ahead and do this. Let's write it over the denominator of 7x. Don't forget that if it's two terms, you put them in parentheses. And that x plus 2 was two terms, because you're going to have to distribute that negative. It's not just minus the x, it's minus the x and minus the 2, isn't it? All right, so now let's distribute. Let's say this is 6 minus x minus 2 over 7x. And some of these things can be combined, right? A 6 and a negative 2, well, that's really just 6 minus 2, so really it's 4 minus x over 7x. And I believe I'm done. I have two terms in the numerator. I have a single term in the denominator, and the three terms do not have a common factor, do they? You can't reduce those x's. This is subtraction. There would have to be an x over here for me to do it with the 4. Okay? Now let's look at the next one. Same thing. I have a common denominator. I'm going to put everything else in parentheses, because I'm going to have to distribute this negative. I don't ever do the parentheses thing unless I know I'm going to have it. I'm going to write it all over the common denominator of y minus 5. And it's going to say y plus 9. Now those don't need parentheses. Do you understand why? I'm not distributing a negative into the y plus 9. But here I've got to say minus y minus 9, don't I? Well, let's do it and distribute that negative. Y plus 9 minus y plus 9. What's it over? Y minus 5. I'm going to parentheses that one so I know I can't just go randomly reducing it. And here I have y minus y, don't I? Well, what's y minus y? Those actually cancel. And I have 9 plus 9, which is going to be 18, over y minus 5. Three terms. 18, y, and 5. They don't all three have the same factor, so they can't reduce, okay? We're not reducing because it's not all multiplication. Actually, that one wouldn't reduce anyway, would it? Next, this one, same denominator, right? So you're going to add those numerators. Now this time you don't have to watch and put this one in parentheses because you have to distribute a positive, because distributing a positive doesn't change anything. So you can just go ahead and add the numerators, and then you must try to factor that denominator, okay? Because it might reduce some more. Go ahead and do it. I'll do it up here, but you can do this one. Okay, there's your solution. I think you're probably all there ahead of me. How's that? Okay? Okay, once again, if factoring is a weakness, that's something you've got to conquer. You can't go forward until you've conquered factoring. It's not something that you're going to be able to get around. all right? It's not going to go away. You have to use it in every single problem, and when you get to college algebra, you got to use it again, okay? So factoring, if it's a weakness, that's where your focus needs to be. Are we good? All right, excellent. Then I'm going to turn this off.